फिर से स्वागत है आप सबको मेरे चैनल में प्यारे प्रोग्राम में। आज का टॉपिक क्या है? लीनियर रिकर्शन। जस्ट लाइक वी स्टडीड इन द प्रीवियस क्लास व्हाट इज रिकर्शन. In the next class we studied different type of recursion, then we studied what is tail recursion, then head recursion. Today's topic is linear recursion. We will discuss in the same way what is linear recursion, how we can apply the linear recursion in our program. Then we'll do the dry run to understand the code more easily. At the end, homework. So let's start. Let's discuss what is linear recursion. It says that if a recursive method calling itself one time, then it is known as linear recursion. Every definition contains a call inside it and one time only. No, we can have more than one time also. Let's see. A linear recursive method only makes a single call to itself. Each time, we have to underline this one, each time the function runs. So let's take an example. If this is my method definition, I am having this call. Till now we have studied this one. This call transfers the control to the header part. It is executing some of the statement inside it. Again, when it is interacting with this call, again it transfers the control to the header part. This is known as recursion. This much we have learned till now. Now we can have this one also. If it is method header, we can have call 1 which will transfer the control to the method header. We can see call 2 can transfer the control to the header part. And these are the other statements. After executing, again it will call 1 and call 2. We can have more than one call. That's what it is talking about. Single call to itself. This is my single call to itself. This is multiple call to itself. More than one call is available. Each time, we can see this one. Each time. Hope everybody has understood. When you will see the program and its diagram, you will be clear more about it. Let's see how we can apply this linear recursion in our program. Here the program says that write a program to find out the factorial of a given number using recursion. Why I have chosen this one? Because we are all aware of this factorial. This one is the header of the method. It's static. Why? Because I want to call this method without creating an object from the main method. Return type is long. Why I have taken long? If you are not aware of it, normally everyone takes it integer. Why I am taking long? If you are not aware of it, then check this video to know the logic of PRS programming in factorial of a given number. Here only we are emphasizing on the recursion part. Method name is FAC. Parameter takes int no. Why this is int? Why this is long? You will get from this particular video. Next, body of the method begins. Base condition, if the number is equal to 1, then it will return 1. Otherwise, it will return n into recursive call, that is FAC of n minus 1. Why n minus 1? Because if I want to find out the factorial of 5, then I have to multiply it with 5 into 4 into 3 into 2 into 1 like this. Because of that reason, every time it is minus 1. After that, I will close it. Look at this, how the code is too much less. Main method, public static void main and the string argument, inside which directly I am calling this method, because whatever result it is returning, I can use it with the print statement to display it. This is the method call. I am passing the actual parameter as 5 to the method. Let's do the dry run. Let's start our dry run. Here, first of all, the program execution starts from main method, and the first statement in the main method is display system.out.print, and inside which I am having a method call. I am not using the object to call this because it is a static method, and we know that the static method can be called directly without creating an object of the class inside a static method. So it will transfer the control from here to here. Arrow mark is indicating this one. What is the value of n? N value will be 5. If no is equals to 1, 5 equals to 1, condition is false. So it will execute this statement. I don't need to use else over here, because if it is true, then it will execute this one. If it is false, directly it will execute this one. Irrespective of else part, it will execute this one. So that's why else part is not used over here. Let's understand this particular statement, which is most important. Return n into FAC of n minus 1, which is a recursive call. Why n minus 1? Because if I want to find out the factorial of 4, then I need to multiply it with 3. 4 into 3, then into 2, then into 1. Like this I have to do. So every time it is subtracted by 1. Minus 1, minus 1. So that's why n minus 1. So let's see, this is the not executable part, n into, this is not going to be executed. So it will be kept inside the stack. And after that, it is going to perform n minus 1. N value is 5. 5 minus 1 is 4. Now it will transfer the control from function call to function header, where n value will be 4. 4 is equals to 1. Condition false. So it will execute this particular part, where it cannot execute this n into, because the control is going to be transferred to the definition. So n into will be kept into the stack, where n value is 4 into. Why 4 into? You can see what is the value of n. N value is 4. It is not subtracted yet. Now it will subtract n minus 1, which is 3. Then it will transfer the control to the method header. Now the formal parameter n is 3. No is equals to 1. 3 equals to 1. Condition false. So it will execute the non-executable part, which will kept in the stack. That's why it is 3 into. You can see quite clearly from here. Now the n value is 3. Then it will subtract n minus 1, that is 2. Now it will call, transfer the control to the definition, where n value will become 2. 2 is equals to 1. Condition is false. Again it will keep the non-executable part n into. So what is the n value? Now it is 2. That's why 2 into will be kept. And the return value of the function is going to be multiplied, because the function is returning a long value. We can see a function is returning a long value. How it is doing, we'll see. After that, 2 minus 1 is 1. Now it will call, transfer the control to the header part. In the formal parameter, n value will be 1. 1 is equals to 1. Condition is true now. So it will execute this particular part, return 1. To whom it will return? The call part. Where is the call part? This is my call part, you can see. I have kept in the stack. So it is going to return the value. You can see it is jumping. Return 1 will transfer the value to this FAC1, which is calling it. So what is the value of this? 1. So 2 into 1 will be executed now. What is 2 into 1? 2 into 1 is 2. So now to whom it will return? Because we have return statement. Here it is 2. Multiplied with this will return 1. 2 into 1. To whom it will return? The previous call. So now it will become 2. So 3 into 2. Now this will execute it. 3 into 2 is 6. Now to whom it will return? Its previous call. So previous call will be 6 now. 6 into 4 will be executed now. 6 into 4 is 24. To whom it will return? Its previous call. This will become your 24 now. 24 into 5. This is 120. Now to whom it will return this 120? The call that is made from the function main. You can see the stack is empty now. When it will execute this one, after this stack will be empty. So 120 will be returned to the function call that is made in the main function. That is the first call that we did. And it is used with the print statement. So what it is going to print? It will print the output as 120. Hope everybody has understood the mechanism of linear recursion. Let's see one more try run to make you understand a little bit more clear. Main function is calling FAC5 where actual parameter is 5. So for the first call, here is the header part where header part 5 and inside which we have FAC of 4 which will transfer the control again. That is my second call to the header part where the header part will receive the formal parameter 4 inside which we have a call again. But before that, can you see 4 into, because during this period n value was 4, during this period n value was 5. When I am saying FAC of n minus 1, it makes it 3. So now after that the control will transfer to the header part again. This is your third call where the header part will contain 3 unexecutable statement, that is 3 into FAC of n minus 1 makes it 2. Now the control will transfer to the header part. This is my fourth call where the header of the function formal parameter will be 2. Not executable part 2 into, because during this period n value is 2 into FAC of 1 where it will transfer the control to the header part again. In the header part FAC is 1. So the base condition is if the number is equals to 1, then return 1. So that's why it will execute this particular part, return 1. To whom it will return? This is my fifth call. Will return the value to the function call part. So this part will become your 1. Because of that reason you can see not executable part 2 and return value here it is 1. So 2 into 1 is equal to 2. Before this we have a return statement again. So that's why again it will return the value. What is the value now it is returning? It is returning 2. Not executable part 3 into. So 3 into 2. The result is 6. Now here we have a return statement. Because of that reason it will return the control back to the function call. What it is returning? It is returning 6. Not executable part 4 into. So the whole result becomes 24. To whom it will return? The first call that we did from the main function. So the main function receives 120 and displays it. Hope this will make you a little bit more clear regarding the linear recursion. It's time for homework. Let's see what it is asking for this time. Find out the output. What is the question? If n value is 134, what is this n value? It is the formal parameter in the method whose value is 134. What is the base condition? N is equals to 1, then return 1. Otherwise, what I am going to do? N modulo 2, which is non-executable part. And the recursive method call is n by 10. This is the closing body of the method. Then what will be my output? Question number 2. If n value is 534, then look at the body. Yes, it is same. Here the show method formal parameter is 534. Base condition is changed. Base condition says that no is equal to 0. Return 1. Okay. What is the unexecutable part? N modulo 2 is same plus n by 10 recursive call. Actual parameter is n by 10 and close of the method. Only this part is changed. So what will be my output? Let's see how many of you can able to do this. With this, thank you.